All right, so here you are with number 3, and you can see our functions are a little different here. We got rational exponents, so we got to make sure we know the properties of exponents as we go through this. So the first thing we'll do is f of g of x. So again, that means we want to take g of x, whatever that is, and we want to plug that into every x in f of x. So this is going into this x right here. Well, how is that going to look? So I'm going to take the x to the 3/4, and then the whole thing is being raised to the 1/5. So this is going into here, and then it's being raised to the 1/5. Well, how do we simplify that? Remember, if you have power to power, an exponent being raised to another exponent with the properties of exponents, you multiply those. So this would just be x to the 3/4 times 1/5 is 3/20. And that is it for part A. So part B, now we're going to do the opposite. We're going to take f of x, so this is f of x, x to the 1/5. We're going to plug that into this x, and then it's being raised to the 3/4. So we're taking f of x, so x to the 1/5, sorry, and then it's being raised to the 3/4. So now we basically have the same thing here, it's just flipped. So instead of this being to the 3/4 raised to the 1/5, this is 1/5 being raised to the 3/4. Well, the properties of exponents, if you have basically an exponent being raised to another exponent, you're still multiplying. So 3/4 times 1/5 is still going to be the same thing as 1/5 times 3/4. So this answer actually winds up being the same thing, which is 3/20. So x to the 3/20 for part B. All right, so let's look at g of x. So again, we're taking this and plugging it into itself. So if I write this out for an illustration, so I'm going to write g of x twice. So this is being plugged into itself. So x to the 3/4, which is then just going to be raised to the 3/4 again. So it's going to look like this. So x to the 3/4 being raised to the 3/4. And again, properties, we wind up multiplying those. So that gives us x to the 9/16. So those weren't too bad. Just really had one step, which was multiplying the exponents. All right, so let's look at another problem. So let's have f of x is equal to 2x squared minus 3x, and then g of x is equal to 4x minus 1. So if you'll notice, the f of x now has 2 x's in it. And that's fine, because when we do the composition, we just have to make sure we plug it into each one of these. So if I do this first, let's say f of g of x, that means that I need to take this right here and plug it into both of these x's. So I'm actually going to write this out to illustrate. I'm going to rewrite the actual functions. So g of x goes into f of x. So it's going into this x and it goes into this x. You're replacing it for those two. So what is that going to look like? I'm going to have the 2 times, plug in my g of x, so 4x minus 1 squared, minus 3 times, and then replacing the x with g of x. So that's what it's going to look like when you substitute it in there. And now, of course, we have to go ahead and simplify. Move this up a little bit. So this is going to look like this. And then don't skip any steps. I'm going to write this out as the multiplication, because that's what 4x minus 1 squared means. It means 4x minus 1 times 4x minus 1. And then I can go ahead and distribute the negative 3 here. So negative 3 times 4x is minus 12x. Negative 3 times negative 1 is plus 3. So this times this, and then this times this. Now I'm going to go ahead and multiply this out, and I still have the 2 out in front. So 2 parentheses, then 4x times 4x is 16x squared. 4x times negative 1 is negative 4x. Negative 1 times 4x is minus 4x. And then negative 1 times negative 1 is plus 1. And then I have everything else still here. So you can combine these first, or you can distribute the two. I'm just going to go ahead and combine the like terms in the middle. So this is 2 times 16x squared minus 8x plus 1, then minus 12x plus 3. Now I'm going to distribute. So that's going to be 32x squared minus 16x plus 2. And then I still have the minus 12x plus 3. And you can see this problem's getting long, isn't it? Well, now we're on the last step, so we can go ahead and just combine our like terms. So we have the 32x squared, then we have minus 16x and minus 12x, which is minus 28x, and then we have the positive 2 and a positive 3, which is plus 5. So we had to do a little extra work for that one. But basically, so f of g of x is equal to 32x squared minus 28x plus 5. All right, let's look at doing g of f of negative 4. So what does that mean? We need to find f of negative 4. So we're going to plug in a negative 4 into here. We're going to get a number, and then we're going to do g of whatever that number is. So remember, whenever you're finding this, when it's not here with the x, when it has the x, it's going to be an expression. When you have a number, it's actually going to be a number for an answer. So first we're going to do f of negative 4. So I'm taking a negative 4 and plugging it in here. So that's going to be, I'm sorry, plugging it into here. It's f of negative 4, so it's going into here first. So it's going to be 2 times negative 4 squared. You're placing it, it's squared. 2's on the outside. Minus 3 times negative 4, and then whatever I get for that value, we're going to plug it into g. So let's go ahead and simplify this correctly. So this would be 2 times negative 4 squared is positive 16, and then negative 3 times negative 4 is plus 12. So this is equal to 32 plus 12, and then that gives us 44. So this right here, this value is f of negative 4. So that is 44. So now what we want to do is find g of 44. So g of 44 means I'm plugging in the 44 into g of x and then simplify. So 4 times 44 minus 1. Again, plugging in here, 4 times 44 minus 1. So that's going to be equal to 176 minus 1. And then that gives us an answer of 175. So g of f of negative 4 is equal to 175. So again, you got to be careful when you're looking. I think in the beginning I said that you're plugging it into here, but it's f of negative 4. So this is going, negative 4 is going into here first, and then it goes into the outside function, which is g of x. And that gives us these two answers right here for both of those. We'll look at, I think I have time to do another one within this part. So let me go ahead and flip this. And let's look at a different function. Slide this down a little bit. So let's look at if f of x is the square root of 2x minus 5. Now bringing in the radicals, g of x is equal to 5x squared minus 3. So let's find f of g of x first, and then we'll go ahead and then we'll do, after that, we'll do g of f of x. So I'm going to rewrite these just to illustrate, especially because I brought in a new function here. And g of x is 5x squared minus 3. So we're taking g of x, which is this, and we're plugging that into every x in f of x. So how is that going to look? I got the square root, and it's 2, replace my x with g of x, so 5x squared minus 3, and I still have the minus 5. So now I just want to go ahead and simplify that. So this would be equal to the square root of 10x squared minus 6 minus 5, just distribute. And then the only thing I can really do here is just combine my like terms. So 10x squared minus 11. So this is f of g of x. Now if I switch it and do g of f of x, so again I'm going to go ahead and rewrite these to illustrate. So I'm taking f of x, which is this, and I'm plugging that in to the x in g of x. So how does that look? So 5, plug in my f of x, 2x minus 5, then it's squared, and then minus 3. So 5 times my f of x, replace that in for the x, square it, and then minus 3. So if you recall, if you basically square a square root, you're just going to get what's inside. So this is going to be 5 times 2x minus 5. Make sure you keep that parentheses there because you're going to have to distribute to 5. And then minus 3. So then that equals 10x minus 25. And then we still have the minus 3. Combine your like terms. So then that gives us 10x minus 28. Okay, so I think this is pretty good examples for you so you can try some on your own. I will set up some practice for you guys and then see how you do with that. So I will see you with the next video.